last example, we're going to find the general solution of the given system. All right, I will say I'm rooting for a complex, because if I get a complex eigenvalue, then I just have to plug in, and it's really easy. So let's go ahead and see if we get that. Of course we are, because I'm talking about it. So again, we have a system of differential equations, and so first find the coefficient matrix. We found the coefficient matrix. Taking the determinant, we took the determinant, we end up getting lambda squared minus 10 lambda plus 34. All right, now, again, I have to use the quadratic formula to find my solutions, and so I get, so I'm using the quadratic formula, I end up with 5 plus or minus 3i. Since these are complex, I only need to take one of these, and so again, I'm going to take the positive, so lambda equals 5 plus 3i. When we do that, we'll go ahead and substitute in. Substituting it. Now, I want to show you something, because I might not have, oh no, I didn't. I didn't have to worry about any negatives on the inside, so we're fine. All right. I mean, that's why you don't have to really worry about the negatives. Like, you have to worry about, and that's why we don't have to worry about 5 minus 3i. All right, because when we're talking about trig functions, you have even odd functions. That's kind of why they repeat. That's why we only have to do one. So 5 plus 3i is what we're doing. All right, so now what we do, we got to find the eigenvector. All right, so we find an eigenvector. We only have to find one. We don't have to find two. And so when we plug it in, we get negative 1 minus 3i, case of 1, plus 5, case of 2, equals 0. And negative 2, case of 1, plus 1 minus 3i, case of 2, equals 0. All right, now, again, go with the one that I say, I can solve this one or this one. Notice that I have a minus 2 case of 1 there, so I'm going to add 2 case of 1 to the other side. When I do that, I can say, oh, hey, if case of 2 is 2, then those two match up. Then case of 1 has to be 1 minus 3i. Again, what I said last video. So case of 2 is going to be 2. Case of 1 is going to be 1 minus 3i. So therefore, there's my eigenvector. Not very difficult to find that eigenvector. So now, again, check to make sure, to plug into the first one, make sure that you get the answer that you need. And then I'm going to write down all the information. I need alpha, I need beta, I need my b sub 1 and my b sub 2. I need those two column vectors. So my alpha is 5. My beta is 3. My b sub 1, my real numbers is 1, 2. My b sub 2, my imaginary, are 3, 0. So I have everything that I need. All right, so now that I have my b sub 1, b sub 2, and my alpha and my beta, now I can just go ahead and solve this. So let's go ahead and solve this. We just substitute. We're substituting into our formula right there. So, I mean, there's really no math, it's just substituting in. So we substitute in. When I substitute in, b sub 1 cosine beta t minus b sub 2 sine beta t e to the alpha t, and this is going to simplify to what we have on the right. X sub 2, now it's b sub 2 cosine beta t plus b sub 1 sine beta t e to the 5t, or e to the alpha t. And so this is what we're left with. And so now this is x sub 1, x sub 2, so don't forget your c sub 1, c sub 2's. And then just write it beside, and we're finished. And we found the solution. So again, when we have complex eigenvalues, or eigenvalues, it's not hard, it's not difficult, and we're finished. And again, this one took, well, again, I did all the work, so it's not going to take you the amount of time this video is. But it's, it's actually going to be really quick. So hopefully you've enjoyed learning about how to solve a system of differential equations. When we're talking about homogeneous differential equations, where the set equal to 0.